All right, for you guys, this is something like page 85.
82.
What?
82.
82? All right. Exponent laws. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5 was all the stuff you did in grade 9. So this should take about 2 seconds. Except in grade 10, we use letters. In grade 9, you only had to use numbers. In grade 10, we add letters to the equations. Otherwise, do the rules change? No, because a rule is a rule. It doesn't matter what it looks like, okay? So in grade 9, you guys learned what to do with this. 2 squared times 2 cubed. You learned what to do with that. You learned what? What is the answer? Two to the power of 5. Why? Okay, so you have been taught a shortcut, how to do it, right, L? That's not why. Understand the difference? By learning a shortcut, that will screw you over when I pile 5 or 6 different ones in the same question. Okay? That's better. That is 2 times 2 times, that is 2 times 2 times 2. That's 5 2s, so it's 2 to the 5th. Now you learn the shortcut, which is 2 to the 2 plus 3, which is 2 to the 5. This is why it works. If you know why something works, if I pile 5 of these laws into one question, you can't screw it up if you know why it works. Now, in grade 9, we use numbers. In grade 10, we change this to letters. X to the m times x to the n equals x to the m plus n. That is what you should know for the 10th grade. Okay? No different, except there's letters. So, we'll come back to that. Move on to dividing. 2 cubed divided by 2 to the 1. That's grade 9. What's the answer? Why? It's 2 times 2 times 2 over 2, right? What happens when I have the same number above and below in a fraction? They cancel out. Everybody says they cancel out. They just disappear, don't they? They don't really. 2 divided by 2 is what? 1. Do we ever write 1 when we're multiplying? No, that's what canceling means. You've been taught by all your math. You just cancel, which is wonderful until you have to cancel a bunch of stuff and you're like, oh, why am I able to do that? Because you don't really know it's dividing. You just think it magically disappears. So they will cancel and I will be left with 2 squared. And the shortcut is 2 to the 3 minus 1. Cool? What is it in grade 10? X to the m divided by x to the n can be written 2 ways. xm over xn always gets me m minus n. I subtract the exponents. Everybody is still good. None of this is new. That's why I'm going through it quickly. You've all seen it before, except you saw it with numbers. Everyone's good, yes? All right. Raising an exponent to an exponent. 3 squared cubed. What's the answer? Why? Because there's 3 times 3, and there's 3 of those. 1, 2, 3, 4, 5, 6 threes. So the shortcut is 3 to the 2 times 3. Everybody good? X to the m to the n is x to the m times n. Now, I'm going to stop there for a moment and just talk at you while you make sure you have all this down. In grade 9, very, very rarely were you asked to apply more than one of these in a question. Very rarely. It was like the bonus question on most of the tests. In grade 10, it's the very first thing you do. You apply all 8 of these in any order to any question. Do you understand? All right. Now we're starting to get a little snaky. A fraction base with an exponent. You saw this in grade 9 as well. 3 over 2 squared. What does that equal? We're getting to the end of grade 9 here. It equals 9 over 4. Why? Because it's 3 squared over 2 squared. The 2 goes to everything because the whole fraction is the base. Everybody cool? So that is why it's 9 over 4. So our rule, and I'm going to write the rule over here because this gets snaky. X over y to the m is x to the m over y to the m. But this gets a little snaky. Don't write this down, just think about it for a minute. What is 3 squared over 2? That's 9 over 2. Why? Because 3 is the only base. Okay? Everybody cool? All right. Exponent of 0. I don't know why this one causes trouble, but I've had to leave a bunch of room for it. I used to write one thing, and then everyone's like, I don't know. An exponent of 0 equals what? No. It equals 1. I'm about to show you why. Everybody, I can tell people that till I'm blue in the face. No, I'm going to explain why. Here's why. First, we write it out. 7,321 to the 0 equals 1. This is why. Everybody ready? 3 cubed over 3 cubed. What math is that? What do I really have in the numerator? I have 27. What else could I write up top? What else could I write there instead of 3 cubed? What's another way I can write it? You just filled out a whole chart on it. 3 times 3 times 3, correct? Everybody cool? And finally, what is the law here? Are these the same base? So what am I allowed to do with the exponents? According to law 2, what do I do with those exponents? It's on your sheet, guys. Law 2. What do you do with the exponents? I got all day. Minus them. Well, let's pretend we're in grade 10 and we say subtract, which is the actual word. You subtract them. So that is 3 to the 3 minus 3, correct? What is 3 minus 3? 3 to the 0. Does everybody agree? What can go on the bottom here? 3 cubed is 27. 3 times 3 times 3. What's 27 divided by 27? 1. What's 3 over 3? 1. What's 3 over 3? 1. What's 3 over 3? 1. What's 1 times 1 times 1? 1. What's 3 to the 3 minus 3? 3 to the 0. If all of these are equal, then 3 to the 0 must equal 1. If that happens once in math, how often does it happen? Every time. People lie and say math is confusing, but it is the only subject that is never confusing because the rules are always in play. There are no times when the rules don't work, like in every other subject. Like in English, how O-U-G-H can make 87 sounds. None of them are OUG, which is the sound it should make. Right? Not like in English, where your house burns down at the same time that it burns up. English is easy, math is hard. Really? Most of you in this room learned English by the time you were 3. If you were an English-speaking house, you learned it by the time you were a baby. Can't be that hard. Except it is. It's the hardest language in the world to learn. So, everybody cool with this? Now I'm going to mess with your heads right now. Don't write. Think. What is 6 to the 0? 1. What is negative 6 to the 0? What is negative 6 to the 0? Negative 1. Why? The negative is outside of the base. What is negative 6 to the 0? 1. Highlight. If you were not able to answer all these questions, which is everybody in the room except Adam, you'd better write that down, because Adam is the only person that said this answer. You didn't say it loud enough, Al. Don't whisper it to Natalie. Get a spine and say it out loud. Yes? I know you have a rugby game today. If you need to go right now, then you need to go. Okay. All right. Right there is the end of grade 9 in Canada. The next thing we're about to do is something that is totally new to anybody that was in grade 9 here, except maybe a kid in my class. I might have shown this to you. I can't remember. The first thing we are going to do is discuss a negative exponent. What would that look like? Well, 3 is a base. The exponent is negative. Now, according to math, what does this mean? I am taking the base, number 3, and I am multiplying it by itself negatively. Does that make any kind of sense? Makes no sense, does it? None at all. So, we're going to talk about what this actually means right now. Everybody cool? Okay. Let's start with what we already know. What is 3 to the 3? 27, because it's 3 times 3 times 3, and it equals 27, correct? Everyone agrees? Okay. What is 3 squared? 3 times 3, which equals 9. What is this relationship? What is happening mathematically between 27 and 9 to get there? It's only 4 kinds of math. Add, subtract, multiply, and divide. Which one are we doing here? Subtraction? Division. I divided by 3, didn't I? Right? And that makes sense. 3 times 3 times 3. Take out one of those multiplies. It's a divide, yes? So what's the next one? 3 to the what? 1, which is what? 3, which is 3. What is happening here? Divide by 3. 9 divided by 3 is 3. Cool? Now, according to the last one we just did, 3 to the 0 is what? 1. And that's divide by 3, isn't it? Now, guys, you're very smart young people. If something happens 3 times in a row in math, it's not a coincidence. It's because it's a rule. So what is our logical next exponent? 3 to the negative 1. I can't write that because it makes no sense, does it? Right? But what must happen here? Divide by 3, so that is 1 over 3. Everybody get it? Okay, so now what's our logical next exponent here? Negative 2. So what is our logical move here? Divide by 3. So this spot right here must be 1/3 divided by 3. But in math, we don't divide fractions, do we? This is 1/3 times 1/3, isn't it? What's 1/3 times 1/3? 1 times 1 is 1. 3 times 3 is 9. Right? Yeah. So notice, 3 to the 1 was 3. 3 to the negative 1 was 1 over 3. 3 squared was 9. 3 to the negative 2 was 1 over 9. So you guys are smart kids. What is 3 to the negative 3? 1 over 27. Is everybody cool? That seems like a really simple topic, yes? Whatever you had, it just reverses, reciprocates, yes? But for some strange reason, this is mind-blowing. This is where all of a sudden my A students turn into crying, drooling troglodytes. And I don't know why. There it is with numbers. Here it is with letters. What is x to the negative m? Three to the negative 2 became 1 over 3 to the positive 2, right? So what must this be? 1 over x to the positive m, because negative exponents make no sense. Is everybody okay? You cannot have a negative exponent because you can't explain it, can you? It's not 3 times 3 negative 2 times. That doesn't exist. So you have to do this. Is everyone cool? Now, I'm going to explain to you why it gets weird, okay? Put all the laws together. What is 4 over 3 squared? (16 over 9). Does everybody agree and understand that? Why? Because 2 has to go to everything, yes? What I really have there is 4 squared over 3 squared, yes? Okay. So what then is 4 over 3 to the negative 2? where does the negative 2 have to go? To both of them. So that's the first step, right, Emily? Does that make any sense? Can I have negative exponents? Ever? No. What happened here? Where did the x have to go? To the denominator. So where does this 4 have to go? To the denominator. 16. Cool? Here's the denominator. Where must it have to go? To the numerator. Because they reciprocate. Does everybody understand? Everyone is cool? Everyone's good? Going once? Going twice? Going thrice? Okay, so now we're going to do something that you knew from grade 9, but it changes in grade 10 because of what you just learned about negative exponents, okay? This one. You learned this. 3 times 2 squared. Last year you learned that this is the same as 3 squared times 2 squared. The 2 has to go to everything, right? You learned that last year. So this year, we just change it to letters. I've written A and B there, but I've been using X and Y up till now. That gives me X to the M, Y to the M. Now this and that negative is what makes exponents difficult for you guys. Now you all, after number 7, should have some blank space, do you? The whole page. Good. That's what you're supposed to have. So let's start, not like grade 9 where we only had to do 1 or 2 things. Let's put a couple together, okay? And we're only going to use letters at the beginning. What is x to the 6th times x to the 3? What would that be? X to the 9th. Everybody cool? Okay. What would x to the negative 3 times x to the 5th be? X to the power of 2. Now, Emily, why did you immediately go to 1 over? Because you didn't like that negative, right? But when you look at the whole question, what do you see? You see that these are the same base, right? So I can just go ahead and add them because it worked out. Everybody good? Everybody good? All right, well, now let's change it. X to the negative 4 times x to the positive 2. What's that one? That would be x to the negative 2. Is that allowed? Then you do flippy flippy, and it's 1 over x squared. Everybody good? Okay. 9x squared times 2x squared. I haven't shown you this. I'm seeing if you can put it together. Who has a guess? What is it, Sean? 72x. Why 72? Where are you getting the 72? Why are you doing 9 times 9? That's not the base, is it, Sean? What's the base? Only the x. So, rethink. You don't have to do 9 times 9. What do you got? Anybody else? Eight. 18x to the fourth. Why? Because 9 times 2 is 18. Numbers go with numbers, just like in multiplying radicals. Right? Now I'm going to mess with your heads. 9x squared times 2x squared. What's that one? So what is it? Pardon me? $324x to the fourth. Why? Because this time there's brackets. So this is really 9 squared x squared, which is 81x squared. This is really 2 squared x squared, which is 4x squared. Then numbers together, 81 times 4 is 324. X squared and x squared is x to the fourth. Everybody good? It's not difficult, but it's precise, yes? You have to be very careful, right? But it's not hard because it's just multiplying, right? Okay, what would you do with this? 15x to the fifth over 3x squared. I haven't shown you what to do with that. I want to see if you can figure it out. 5x3. Why? Because numbers go with numbers, and the letters go with letters. 15 divided by 3 is 5. X to the fifth divided by x squared is x cubed. Right? Okay. What about this one? Why? Numbers go with numbers, letters go with letters, and the y is dividing by nothing. So it stays as a y. Is everybody cool with that? All right. Let's try 21x to the fifth, y to the -3. No, I lie. Y to the fifth over 7x to the seventh, y to the third. Three, because numbers go with numbers. 3x. What's 5 minus 7? -2. And what's 5 minus 3? +2. What there isn't allowed? The negative exponent. Where does he have to go? To the other place. If he's on the bottom, he's got to come up. If he's on the top, he's got to go down. 3y squared over x squared. Is everybody cool with that? Okay, now I'm going to give you the hardest one, kind of one you're going to face today. Emily. Negative exponents have to move. Yeah. So this term has to be the thing that moves because that negative exponent is not allowed. That's how you know. Because 5 minus 7 is negative 2. Okay. Oh, I see. Well, you'll see what I mean right now. Okay? You'll see what I mean right now. 12 x to the 6th, y to the 4 over 16 x to the negative 6, y to the negative 3. That's as hard as we're going to do today. Correct. Why? Numbers go with numbers. 12 over 16 is negative 3/4, isn't it? Everyone agree? It's grade 3 math, right? Mrs. Bad Crumble taught you how to do fractions. Everybody's good, yeah? What? Letters with letters. What is 6 minus 6? 6 plus 6, which is 12. So since he's positive, he stays here, right? What is 4 minus 3? Because it's 4 plus 3. So because he's positive, he stays here. Got it? Now, Emily is asking, well, what happens if I have a guy down there? So what Emily is asking is, if I have the same question, but now there's nothing here, is there? So that's going to be negative 3 x to the 12 over 4y to the negative 3, because the negative 3 is already down there, yes? Is that negative 3 allowed to be there? Go for Myers. Yeah? It was on Greg DeVries' desk this morning at 7:45. He is. I don't know. He might have gotten that, or what's her name? I can't remember her name. Okay. Is that allowed to be there, Emily? Why? Because it's a negative. Negatives can't exist. So since he's already in the bottom and he's negative, he's got to come up. So this guy would become negative 3x squared y x to the 12th, y to the 3 over 4. Now, here is the thing that screws you guys up. What isn't allowed? Negative what? Exponents only. Is this okay? Why? Because it's not an exponent. It's a base. Okay? I can't make it any simpler. All of you are going to write the test, and all of you are going to flip this over at least once. Negatives aren't allowed, Mr. Myers. And then I'm going to go back to today on my video, April 5th, and I'm going to say, we're going to play you this part where I say negative bases are allowed. Okay? Okay. Now, if you look in your pink, I lie, your blue book, which is your workbook. So let me double check something. No, I lie. I'm the worst kind of liar. You guys, if you keep in your notebook, which is pink, your next page should say basic exponent rules. Excellent. Do those. Up to number 35. I know. But they're mostly one-steppers, maximum of 2. Okay? Sean? No, because we're going to go on past this and I don't feel like walking down and getting you. Okay? I'm not trying to be a dick, but this is easy enough that you can handle here. You guys are going to do that. Oh, I'm sorry, guys. I'm being the biggest dummy. I just said start working, and I'm cutting into your attention time. Please, in your book, there was an outline on page 65. Okay. What do you notice happened right after, in the outline, after multiplying radicals? What does it say? Mid-unit test on radicals only. Have we done that mid-unit test on radicals? No. We are going to do that. I don't normally do this to you, but we're going to do it Friday, and here's why. I may not be here Friday. I may take the day off because I'm going to the hospital for some surgery that day. But I don't have to be there until the end of the day. But part of the preparation for that surgery is a bunch of medicine I got to take. And that messes with you. Okay? I don't know how I'm going to react to that stuff. Okay? So I may not be here Friday. So we're going to plan to write this test on Friday, which is everything up this way. Okay? All right? Tomorrow, we're going to move on to doing some work out of our workbook, which is the blue book. Okay? But right now, we're just working on the sheet. Everybody cool? Okay. I apologize for cutting into your work time. Go back to it.